So when working some of these absolute value application problems, you're going to run into what are called your variance problems. And your variance problems are going to kind of run into this formula down here at the bottom, where you're going to have the absolute value of x minus whatever the actual value is in the problem equals, and then how much that actual value can vary by goes over here. Now let me explain that using this problem right here. So Sam runs track and can run a 400-meter distance in an average time of 83 seconds. The fastest and slowest times he runs can vary from his average by 6.4 seconds. Write an absolute value equation that can be used to describe the fastest and slowest times he can run the 400-meter in. All right, so there's some values that we want to pay attention to in this problem. One value is going to be this 83 seconds, and that is the actual time that he averages on this on his run for the 400 meters. And then we have this 6.4 seconds, which is your variance. The variance is what your actual value can change by. So he can run an average of 83 seconds, but sometimes he will run up to 6.4 seconds slower. Sometimes he'll run up to 6.4 seconds faster. So he can run anywhere in that area is where he will typically run the 400 meter in. So if we're going to set up an equation, we're going to use this formula down here, and so we're going to have the absolute value of x minus his actual time of 83 seconds equals his variance, which is 6.4 seconds. Now, if you think about this, he can average 83 seconds, but sometimes he runs a little slow. Maybe he ate too much for lunch or whatever the case may be. And so you would add up to 6.4 seconds to that. So it might take him as much as 89.4 seconds. Or he may be running really well today, and he runs 6.4 seconds faster, which means you would subtract 6.4 seconds. Which would give you 76.6 seconds. That's as fast as he probably could run. So if you think about the values here, the 6.4 could be a positive value or it could be a negative value, because you could be adding that to your time, you could be subtracting that from the time. That's how much it varies by. Now, when you solve an absolute value equation, remember that you write two equations. One equals the positive value, and one equals the negative value. And when you solve, you would be adding this 83 over here on both situations. So you would have a positive 83 plus 6.4 for one of your equations, and a positive 83 minus 6.4 for the other equation. It would look like this. You have x minus 83 equals 6.4, and you have x minus 83 equals negative 6.4, giving you x is equal to 83 plus 6.4 seconds, and x is equal to 83 minus 6.4 seconds, which will give you these two values right here. And so this is your absolute value equation that will generate this with your variance. So you have absolute value of x minus what your actual value is equals, and then how much that value can vary by. All right, so let's look at another situation here. It says, Mr. Sassman, that's me, drives to work from New Braunfels every day. My average drive time is 25 minutes, but that can vary by as much as 4 minutes depending on traffic. Write an absolute value equation that can be used to find the fastest and slowest drive times to work. All right, so using the formula from the other side, you're going to have absolute value of x minus the actual time that it usually takes me, which is 25 minutes, equals, and then how much it varies by, which is 4 minutes. Because if I solve this, you'd have x minus 25 equals 4, and x minus 25 equals negative 4, giving you 29 minutes, or it could be 25 minus 4, which is 21 minutes. So it might take me as much as 29 minutes. It might take me as little as 21 minutes to be able to drive to work. And just to throw in one more good example here, Jacob really likes Skittles. He timed himself for 2 minutes to see how many Skittles he could eat within this time limit. He did this every day for 2 weeks. He found that he could eat an average of 52 Skittles in 2 minutes, but this number actually varied by 6 Skittles depending upon what he ate for lunch. Write an absolute value equation to represent this peculiar fascination. All right, so you're going to have your absolute value of x minus the actual value that he averages here, which is 52 Skittles, equals, and then how much that varies by. Well, it says it varies by as many as 6 Skittles, so that is our variance. And if we were to solve this, you would have x minus 52 equals 6, and x minus 52 equals negative 6, giving you 52 plus 6, which is 58 Skittles. Or you could have 52 minus 6, which would be 46 Skittles.